Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is minimum string after minimum string length after removing substrings. Okay, so you will be given a string S consisting of only uppercase English letters. Okay, and you can apply some operations on this given string S, in which one operation you can remove any of the occurrence of the substrings AB or CD. Okay, so if AB is occurring anywhere in the given string S, then you can remove that occurrence. Similarly for CD, if it is occurring anywhere in the given string S, then you can remove that occurrence. Okay, and after you are done removing applying all possible operations you can, then you have to return the minimum possible length of the resulting string that you can obtain. So our aim would be to do or perform maximum amount of such removal operations of either AB or CD or both. Okay, and after those operations are executed, then we have to return the minimum resulting string, minimum length resulting string that can be obtained, and we have to return the length of that string. Okay, and note that the string concatenates after removing the substring and could produce new AB or CD substrings. Okay, so there might be a case that after removing a certain substring, okay, you will be producing a new substring that is also subjected to the removal. For example, let's say something like this was happening: AA, then A came, okay, and then B, and then let's say another B came. Okay, so if you remove this portion, then the string concatenates and form this AB again. Okay, and let's say before this there was some G. Okay, so then again you see after this removal these two come together, and these two again form AB, and which is also can be removed. So after removal only G is left. Okay, this is what the problem statement is saying. So string kind of heals itself, and the characters come close, and basically they do a concatenation, and if it is resulting into another AB or CD, then you can remove that one also. Okay, so before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of the string is of order 100, and it is consisting of only uppercase English letters. Okay, so let's try to think of an approach. So for these kind of problems in which you are dealing with concatenations after removal and possible formation of the words which can also be removed, stack is a good choice, because we are just searching for the previous character. Okay, okay, and also we have to keep track of whatever went before that one. Okay, so it's last in first out kind of order. Okay, so LIFO, last in first out. Okay, so stack will operate like this. Firstly you will insert a character. If stack is empty, okay, we are fine. Let's say the given string was this only: GAAB and then B. Okay, so then again you will be seeing what is at the top of the stack. If either C or A, if C is at the top of the stack, then your current character must be D in order to remove the top of the stack. Okay, and if it this is not the case, then if let's say the top of the stack is A, then your current character should be B in order to remove this one. Okay, and if neither of these cases are there, then you can safely add the character to the tag. Okay, so here neither of these cases were happening, so we straight away added a to the top of the stack. Then we came across another a. While see, we will be doing the traversal while we are traversing the string character by character. Okay, so now we are at this a. Okay, now again the top of the stack is a and the current character is not b. Okay, but it's a, so we will be adding it to the top of the stack. Okay, so now for the next character you will start noticing the magic of the stack. So as soon as you see one b, then this condition becomes satisfied. The top of the stack is a and the current character is b. Okay, so you will be removing the top of the stack. Okay, done. Now you will be moving to the next character. Okay, so now you will be moving to this particular b. Okay, so now this is already gone, so let's remove this. Now your top of the stack is again a and this particular condition is again satisfied. Okay, and your current character happens to be b, so you will be removing your top of the stack. Okay, in this particular case, uh, after you are done traversing the last character and doing all the operations along the way, then whatever will be the size of the stack remaining will be the minimum length resulting string possible. Okay, so now the size of the stack happens to be 1, so you will be returning 1 in this case. Okay, so this is how you will be using stack to solve these kind of problems. Okay, and this is the implementation uh, logically, but now let's see it programmatically how we can implement it in the code. Okay, so let's take a fresh slide for that and let's bring the code to the board. C++ implementation will also be available for this one. So without further delay, let's bring that code to the board. So this is the code. Okay, so let's uh, discuss what we are doing here. So as I talked about that we would be needing a stack, so I am calling this character stack. Okay, and then since we will do the similar work that we were doing a linear traversal and visiting each character one by one from left to right direction. Okay, this is what we are doing here. Okay, then if the stack is currently empty, then there is no character in the stack to do comparison with, or to see whether we would be able to form something like this a b or c d. Okay, so okay, and then we will uh, add the character to the stack in that case. Okay, and if it is not empty, then we will do the comparison and we will be seeing what is on the top of the stack. Okay, so if either of these two conditions are satisfying, okay, these are these two conditions we are talking about. Okay, so either the top of the stack is a and the current character is b, so you will be forming ab. In that case you can remove the top of the stack. So similarly this is the case for cd. Top of the stack is c and your current character is d. Okay, so in that case you will remove the top of the stack and you will not be doing any addition to the stack. Okay, so if that's not the case, then you are safe to add the current character to the stack. Okay, and after you are done with all these operations and doing while doing the linear traversal of the string, then you will simply return the size of the stack stating uh, or which will be indicating the minimum length resulting string possible, minimum length of the resultant string possible. Okay, so as far as the complexities are concerned here, time complexity wise, see, since we are doing a linear traversal only, if let's say the string is of size n, then it's order of n. And since we are using a stack to store the characters, okay, so space complexity will also be order of n. Okay, so these are the complexities. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSS skills. Keep solving more and more problems, and I'll be seeing you in the next video. Thank you for watching.